Alright, in this video we're going to do our first actual example of a program. I'm going to do a Tic Tac Toe program. Uh, it's going to be very rudimentary. It's just going to have the first player always default to a human player, an actual user that would choose which square they want to put their X in. And the O, which would be player 2, will always be really, really dumb AI. Just the computer will randomly choose a spot that's available on the Tic Tac Toe board. For those who don't know, basically, Tic Tac Toe's a children's game. It's set up like this. You have this little pattern that gives you nine spots to place an X or an O, depending on which one you are. And the way that I'm running it, X's go first, the human goes first, they're X, the computer's second, and they choose O. You choose some spot that's open. Like, if you're going to O, for example, in this case, if the player one's already chosen the top left corner here, then O has to choose one of the spots that doesn't have an X in it nor has an O. It's only open spots. And the idea of the game is to get 3 of your symbols in a row. So 3 X's or 3 O's in a row will win for whichever player has that appropriate symbol. And you can win by getting 3 in a row either horizontally, vertically, or diagonally. Either one of those works. And then, you can actually have a tie game if all 9 of these squares get filled in, and then there's not a situation where there's 3 in a row anywhere. Then it just becomes a tie game. But anyway, I started off on this little virtual whiteboard to kind of show you the thought process and like how I kind of try to think and go through programs as I'm building them. I highly suggest you start doing this. Like my second semester in the undergraduate program for computer science, I had a professor make the statement that it would save you a lot of time and headache and debugging if you would just draw pictures and write down your thought processes and what you're doing and all that kind of stuff. And of course, just like pretty much every student, I promptly ignored that advice and would just type as I went, just program as I went, which is always a bad idea. Flash forward to like my first year as a master's student in computer science, and I finally listened to his advice and started drawing pictures and writing down what I'm doing, and it saves you a lot of headaches. So that's what we're going to do. The way I was thinking this is I went through and I was like, all right, what do we need to do? What do I need to do for this tic-tac-toe game? Well, first of all, I need to be able to draw a board, the game board. And kind of as part of that same problem, I need to be able to have some kind of marking system so the user knows how to choose which square. I also need a way to keep the board drawn and put the X's and O's in there also. So I need to worry about that with drawing the board. Also, secondly, we need the ability to let the user choose and process. Let the user choose what where they want to place their X, and also a way to kind of error check that to an extent. That way, for example, if they've already got this spot and they try to choose this spot again, we won't let that happen. And then similarly, we need a way for the AI to choose, and the same rules would apply. The AI would need to be able to choose and have some kind of error checking. So when they randomly chose a spot, if it was already taken, it wouldn't be a valid choice, and it would have to choose again. And then finally, we need a way to validate if there's a winner. So that's basically the steps. The 4 basic steps or processes we need to worry about. And I got to thinking about it, and I was like, well, I think an easy way for the user to actually know where to choose is, what if instead of having a blank game board initially, instead of doing that, we just go ahead and mark each square with a number, like so. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I can think, well, if I do it that way, then it's pretty obvious you hit 1 to go here, 2 to go here, and then say if the user chooses the first square, 1, and that 1 just gets changed into an X, and then they know that they can't choose that anymore because there's not a number associated with it. So that kind of took care of the marking part, and then I was thinking, well, I could use the same system to do the X's and O's. But speaking of system, like, well, how would I store this data? Well, to me, using this 1, 2, 3, 4, 5, 6, 7, 8, 9 pattern associated a number of, to each one of the squares, and on top of that, all the data is associated. And to me, that just screams list, which we've talked about. So I was like, okay, that's the plan. I can make a list and I can seed it initially with, where like this position has a 1 in it, this position has a 2, so forth, so on. And then that having that list with the order will give us the ability to also be able to just keep it all compact and nice and pretty and easy to mess with. Now moving on to the user choice and the AI choice, I'll explain a little bit more how I did that when I get to the actual code, which I'll show in just momentarily. But I will say with the AI, I used a library package that Python has built in, which is just called random. So you'd say import random, and I'll show where I did that at the top of the code when I show it. And that's actually one of the many built-in libraries that Python offers. It lets you generate pseudo-random numbers. I say pseudo-random because you can't actually use pure software to generate true random numbers, because every program you write has some sort of algorithm behind it, some sort of system of emotions, like a system that you set in motion, or an equation, or however you want to think about it. So, if you have some kind of set equation or algorithm to make numbers, and they're not really random. You can make them appear to be random, but they're really not. So that's basically what I did, and I'll talk more about that in just a second. And finally, validation. I got to think about that, and I was like, okay, well, since I initially start these things off with with the values 1, 2, 3, 4, 5, 6, 7, 8, 9, none of them are the same initially. So the only way that these any three given a direction of diagonal, horizontal, vertical, the only way three of them could be the same is if they're all X's or all O's. So I figured out it was just a simple comparison to take care of the issue of seeing if there's a wind, just checking all the possible directions. Well, not all the possible directions. Like, for example, if I check from left to right here, there's no point checking right to left, because either way you'd have a winner. So it's just part of the possibilities. But anyway, let's get to the actual code. Let me go ahead and close this out. And I'll go ahead and say now, I'm gonna copy and paste the code over as we get to each section, and I'll explain how it works, and I'll also show it as we go along. I didn't want to burn myself by trying to type and talk at the same time, because it's always disastrous for me. So I just went ahead and did the code in advance to make sure it worked and all that kind of good stuff. But so as you can see, I divided the basic code is divided into 1, 2, 3, 4, 5, 6, 7 functions, and I'll have some main code down here. I have the print game board function, which prints the game board out. As you can see, I'm using the printf style notation to print the board out, which is why I wound up just doing a video. The last video I wound up just doing over printfs. This one's a lot simpler than the examples I showed in the previous video, because I'm actually just using nothing but strings. Like I keep like the board list, which will hold the values for the board, whether it's X's or O's or the numbers. I just kept them all in a string format. So instead of using the literal number one, I use the string version of one. And the reason I do that is because it lets me just have one version of printing the board. I don't have to do a bunch of checking to see if I need to print out an integer or if I'm printing out a string. So it just makes that easier. This doesn't actually look like a very pretty game board. You'll learn as you play with input-output, especially with a console. If you want formatting, a lot of times you just have to play with it. And when you write the code, it doesn't look like what you would expect. But when you actually run it, it'll turn out okay. Case in point, I went ahead and set this up with a seeded board list, and then I just call the function to show the board. And as you can see, I have a Tic Tac Toe board set up there with the numbers inside of them. And then since I just set these up as the number values is the string version, and then I just replace them with the strings X's and O's as people choose, then I don't have to change this function at all to make it work, because it'll just be a string. These will always just be string values. So the other thing I'll go ahead and note is you'll notice it has the keyword pass on all these functions. What pass lets you do, and you can do this with functions, if statements, while loops, for loops, all that kind of stuff. You can put the keyword pass inside of there, and what that'll do is say, hey, I'm going to go ahead and have an if statement here, or a function here, or a while loop, or what have you, but I'm not actually going to put any code inside of it right now. I'm going to come back to it later. And if you want, and that just lets that's basically all it does. It just lets the interpreter know that, hey, this isn't a mistake. I did name this thing. I just haven't written any code to go along with it. So if you don't do that, like if I comment this line out where the pass is not there, then you'll see that it'll actually throw an error because it doesn't know why I defined this function and there's nothing associated with it. So that's the whole point of the pass, one thing about it. Okay, moving on. Let's just kind of go, well, first of all, there's the print from the game board code. I'm just printing to the screen using the printf notation. You guys can kind of copy that if you want and play with it. Because like I said, with the input output with console, a lot of times it's going to look funky when you write it down. You have to write the code down for it, but it'll, look okay when you print to the screen. There's no tricks to make it look pretty. It's literally just get an idea of what you want and play with it. I spent about 15 minutes or so playing with it after I initially, from the initial time that I initially started printing this stuff out to the time I got it to look right. I just played with it for like 10 or 15 minutes, added spaces and removed spaces, put tabs in, set the strings and stuff like that. But anyway, we're just gonna kind of go through this in order. Like we have a function that we talked, like I talked about. We need to be able to choose a move. So we're on step 2 now. Step 1, of getting a game board that prints out all the stuff is taken care of with this function. Step 2 is to give the user the ability to choose where they want to go, or which square they want to occupy with their X. So how I did this, and let me go ahead and just copy this code over, and I'll explain it. Is I set a Boolean value to, or made a variable called valid move, and I set that to false. And then immediately after that I go into a while loop, and I say while not valid move. And you guys can remember from earlier videos, all the not does, it's a logical operator. It just flips the value of whatever you not. So, and for a while loop to run, the while loop will continue to run as long as there's a true evaluation inside of it. So by saying not valid move, it just turns the false that's initially in there to a true. And then what I do is I say print the game board out so the user can see it and see where their options are at. And then I prompt them using raw input and ask them to choose a square. And then at this point they can see the game board and hopefully they choose a square that's eligible for occupation, an empty square. And so this runs first inside. There's a couple things going on in this one line of code. This runs first and returns the string of what they entered. Now remember, with raw input, when you get input from the console using raw input, it always, let's say always, returns a string. So if you're expecting a number or float or something like that, you have to manually convert it yourself. And I need to access the list that's associated with these different spots in the Tic Tac Toe board. I need a number because with a list you use 0 through whatever, depending on how many elements there are to access the elements. So I go ahead and say, as soon as they enter the data, I go ahead and convert it to an integer, which makes sense because you need to be able to have an integer to access to choose which offset you want for the list. But then you notice I subtract 1 from it right here. Well, the reason I do that is to make it more aesthetically pleasing for a human user. The more you program and you do things like these lists and arrays, you'll get used to the idea of counting starting at 0. But generally, humans don't think that way. We are used to counting from 1 on up, so 1, 2, 3, 4, etc. So to make it more aesthetically pleasing for them, for the user, I chose, it's arbitrary, you didn't have to do this, you could have said 0 through 8, but I chose to make it 1 through 9. But the problem with doing 1 through 9 is, this is actually, according to the list that holds the data, this spot is actually offset of 0. So to access it, you'd say 0. This is 1, this is 2, 3, 4, 5, 6, 7, and 8. So by having them enter 1 through 9, we're going to run into a situation where we're going to have an off by 1 error, which means that if they only enter the numbers that they know about, then they're never going to be able to access this spot, for example. And if they try to access here, they're going to go outside of the list, which will cause a problem. So by subtracting 1, it just readjusts their choice to the proper spot in the list. Like I said, you didn't have to do that. You could have set the list up to say 0 through 8, and then they could have just entered that, and you wouldn't have to worry about subtracting 1 because it would have matched the list. But that was just a choice that I made to make it more aesthetically pleasing. Also, I should note here that I do not actually error check. Like, if they did enter 999, I don't actually check to see if it's valid data. I just assume it's valid data. is you guys mess with this. If you guys copy this program down, there's some suggestions at the end that I'll have for things you can try to do to get some practice and make it a little bit more of a fancy program. One of the things would be to actually error check this to make sure that they enter a valid number. I mean, I'm doing the error checking down here to make sure they don't try to choose a square that's already occupied, but I mean valid input as in make sure they don't enter a number that isn't going to be acceptable at all, like 500 or something like that, which would just cause problems. And then I go after they've made their choice and I adjust it to the number for to adjust for the off by one error. I say if board values of square choice doesn't equal x, the character x, and board values of square choice does not equal o, there's only three possibilities in any given square. It's either going to have the string version of the number associated with it because there's nothing in there, or it's going to be an x or an o. So I know if it's not an x, and I know if it's not an x and it's also not an o, then that means it must be just have that default string version of whatever number in there, which would mean that it hasn't been chosen yet. So if that's the case, if it's neither an x or o, then I know it's safe to go ahead and override it and make an x there. And then I set this valid move to true. That way, when it comes back up to the while loop, it'll break the while loop. Because I'll say I've got a valid move, so and then when you flip that with a not, it'll become a false and break it. So I know this might be a little bit weird of looking like why you might think why didn't I just say valid move equals true and then say why valid move and switch it to false. Well, to me, it just seems more readable this way because it's what you're looking for. You want to keep looping as long as there's not a valid move. So that's why I set it up that way. And then finally, I return check for when of board values. So I don't know if I already talked about this in functions when I did the functions video, but you can actually return a function, so to speak. And what will happen is it'll just go into this function, do its thing, and then whatever value that function returns will get copied and pasted here, and it'll return it back to wherever. Choose random. I'm just going to flop that down. This is like 99% the same. The only thing that's different is there's like one line of code that's different here. Matter of fact, I was lazy enough that when I was writing this function, I just copied and pasted stuff over and changed the one line. The only difference here, like everything is the same, with the exception of how the choice is made by the AI for the square. And this is what this says. Choose random just means that the AI is randomly choosing the spot. So I imported a library called random that gives you the ability to do pseudo-random. You can get pseudo-random numbers using the functions that it offers. And I called the randint function. So I said random.randint, and then I passed the arguments of 0 and 8. What randint does is it expects two arguments. Of the two arguments, the first number has to be less than the second number, and what it does is it does inclusive. It does an inclusive, or it returns a pseudo-random number that inclusive of the two arguments you gave. When I say inclusive, that means it includes these two values I entered. So it'll return a number randomly that's either 0, 1, 2, 3, 4, 5, 6, 7, or 8. Which is perfect because to get to any one of these, to access this list, I need an offset, the pass in there of 0 to 8. So it fits through there. You have to say board list sub 0 or sub 1 and all the way to sub 8 to access the values. So it just picks one of those, and once again I check, and if it's not X and it's not O, that must mean it's an empty square, and I replace it with an O. Otherwise, it just loops back up, and I keep doing random numbers until I'm done, or until it gets one that's valid. And then once again, I check for a win, and I return the board values. Now these check for a win, right here's what I'm calling, but check for a win I'm going to go over last because I've actually broken the problem of checking for a win into 3 subproblems. That's checking all the horizontal rows, checking all the vertical columns, and checking both diagonals to see if any of those are winners. And check for win will merely just check all of those. Just call the functions to check all of those and see if we have a winner. Now, starting with choose or check horizontal, what I did, let me get a copy and paste it over here. What I did is once again, I took a pessimistic approach, so to speak. I just went ahead and made a Boolean value, or made a variable called found win, and I made a set of Boolean value of false into it. And what I'm doing here is I'm just going to go ahead and make the assumption that there's no winners. At least when I check horizontally, I'm not going to find a winner in any of the cases. And then what I do is just I assume that, and then I go through and just use this if, elif statement. And what I do is I just check if you actually like, look at the board here. Do I have it over here? I kind of pull this beside it or above it. If you look at the board, they got to remember this is the list. So these are going to be off by one. So board value of 0 is the same thing as this one slot. Board value of 1 is the same thing as this one. Board's value of 2 is the same thing as this one. So I say if all three of these are equal to each other, which by the way, don't get used to this notation if you go into other languages. I just kind of find out that Python lets you do chain multiple comparisons together like this. Most languages won't. Most languages would have you can only do one comparison at a time, and then to chain them together into one big statement, you have to use like ands and ors and stuff. But this one just let me just do a straight comparison across, which I thought was kind of neat. But anyway, so I just say if board's value 0, board's value 1, and board's value 2 are the same. So if these three are the same, then I know I've got a winner. So I set the found win to true. And the same thing. If this fails, I go to the next elif, which just checks the second row. If it fails, I go to the final elif and check the third row. And if that fails, then there's no point in having a default else to set found win to false because I've already done it up here. And then I just return the result. So if any of these any of these three rows are all equal, then I will set found win to true and return true. Otherwise, it just goes through does all the checks and just returns the false. Check vertical is going to be the same idea. The only difference is the values inside of, or the offsets inside of this. That's the only difference. Instead of checking across, I check the possibilities with 147, 258, and 369. But once again, this is a list, and we start with an offset of 0, so it'd really be 3, 6, or 0, 3, 6, 1, 4, and 7, and 2, 5, and 8. But I'm just checking all the verticals. Same thing here, same setup. I assume that I'm not going to find a winner, then I check all the vertical possibilities. If any of those work, then I set the boolean to true and return it. Otherwise, I just return a false. And then diagonal is yet again the same idea. The only difference is I have less if statements now because there's only two possibilities, which is 0, 4, and 8, or 6, 4, and 2. The two diagonals. So I just check diagonally, and once again, if they're all the same, then I know that they have to be X's or O's. And notice I just say that I found a winner here. I don't actually say who won, I just say there is a winner. So we still have the problem of how do we know if it's the computer or the human that won. But we'll get to that in a moment. I actually take care of that in the main part of the code. Finally, with the check for win statement, go ahead and copy that over. With the check for win statement, all I do is once again in this function, which gets called, this function is one that actually will get called, and then it'll call the other three, the subproblems. Once again, I just assume false, that there's no winner. And then I just go through and I say, and then also with if statements, I did this in the return. You can actually call functions inside of an if statement too, as long as you can make a true-false comparison with them. Like here to make it very explicit, I say, for example, if check horizontals of board values is equal to true. You don't actually have to have this equal to true. You can just say if check horizontal boards values, because we know that it returns that these three, check horizontal, check vertical, and check diagonal, actually return a boolean value, a true or false. So that would be good enough. But just to make it explicit, just to make it explicit, I go ahead and put equals true in there just so it's more obvious. As you guys get used to the code, then like normally I don't do this because I know that this part would be sufficient. But and once you guys get comfortable, you'll probably start doing the same thing. But it's always a good idea to write stuff as explicit as possible, at least at first, because you're not as concerned about efficiency as much as learning the ideas and how to do things. But anyway, I say if check horizontal board values is equal to true, so it calls this function, and if I find any horizontal values, if I find any horizontal set that's all the same, then I set game 1 to true because I know somebody's won the game. Yeah, and then the same thing I do elif again with check vertical and check diagonal. So if any of three of those wind up being true, then I set game 1 to true. Otherwise, I just return it with the default value that I gave it, which is false. And And that's pretty much it for the functions. I'm going to go ahead and delete this print game board in the main part of the code, and I'm just going to copy everything down all at once and kind of explain uh, my logic for the main part of the code, so to speak. Um, okay, so for the main part of the code, I made the board list and I initiated it with string values 1 through 9 in order, because that's what the user's going to see as they're making the choices on the board, and those will get replaced with the X's and O's. I have a Boolean value called 1 that I set to false, and I have another value that I just put the integer 0 in, and then I start a while loop that says while not 1 and keep make sure it's an and here, not nor, like both of these have to be true. So while not 1 and the turn is less than 9. Okay, and I know you're probably thinking, all right, not 1, that makes sense, because, until I know there's a winner, we need to keep looping through and getting people to choose their stuff, but what's up with this turn less than 9? Well, as I stated earlier in the, when I was talking on the, as I was doing the little whiteboard thing, it's also possible to tie in this game, and if you actually, since I'm counting starting from 0, so, if you actually counted starting from 0, if you count up 9 times, or, once for each one of the 9 squares, to assume that they would be filled, then you would get to the number 8. So I know after the 8th turn, after the 8th time this thing is ran, if I still don't have a winner, then I know that it's a tie. And if it's a tie, there's nothing that the users can choose or the AI can choose, so I need to break out and just announce that there's a tie. So that's the logic behind counting the number of turns in the game. And I'll also use it to go back to the problem earlier of knowing that we won, but how do I know who won? Well, I'll also use which turn it is to help me figure out who won the game. So inside the while loop, I have an if statement and an else statement. I say if turn mod 2 is equal to 0. So if turn divided by 2 has a remainder of 0, then it must be an even turn, because all even numbers are divisible by 2. And since 0 is also considered an even number, I know that and then I arbitrarily chose to have the player go first, by the way. But since 0 is considered an even number, then I know that and you alternate turns between the two players, then I know that if it's an even turn, it's going to be player one's turn every time it's even. So that's the logic behind that. And then I say 1 equals choose move board list, which would call the choose move function here, which allows the user to choose a move. And then at the end, you notice how I say return check for win. Well, I go ahead and return a true or false, indicating if the person won, and it gets saved into here. Then I say else. There's no point in saying if. There's no point in checking to see if the number's odd, because if it's not true, it must be odd. So that's why I just go to a default else. Well, if it's an odd number, then I know it's an odd turn, which means it's the AI's turn. So once again, I say 1 equals, and I have them randomly choose a spot on the board. And once they're done with that, that function runs. And they're done doing that. It checks for a win again and returns a true or false if I found a win. And then I increment the turn by 1. So this to kind of give you a reminder of this notation, because it throws a lot of people off until they get used to it. I say turn equals turn plus 1. Well, all I'm doing is increasing the value of turn by 1. What happens is that the assignment operator has a really, really low precedence, which means that everything on the right side of the operator is going to happen before it gets saved into the variable on the left side. So I get the old value of turn, which is, like say initially the old value of turn is 0. So I say 0 plus 1 is equal to 1. I save 1 in a turn. Next time the turn comes through, then the old value of turn is 1. So I say 1 plus 1 is 2. And I save that in the turn. So it just increases it by 1. And that's used, like in this instance right now, it's just barely being used to keep a track on whose turn it is, because I can base the idea if it's even or odd on whose turn it is. But then as soon as the while loop is broken, either because of a tie or because somebody won, then I'll use turn for another purpose. So as soon as this while loop breaks, which means somebody won or there's a tie, I print out the board list once again to let everybody see see the finalized game board. And then notice here I say turn equals turn minus 1. Well, the reason I do that is because, say for example, we're playing and it's like so many rounds in, and we're at this section right here, and the player chooses their move and they win the game. Well, yeah, since they won the game, the while loop's going to break. but turn's still going to get incremented one more time before it loops back up here and realizes that the while loop's done and moves on, which means that we're going to once again have an off by one on the turn. So like say if it actually say like I don't know, uh, say turn 6, the player wins in turn 6. Well, this turn 6 gets turned into number 7 as it comes down here before the loop breaks. So if I try to just use straight up turn as which turn number it is, whether it's odd or even, to determine who won, I would be off by 1, and it would look like the computer won when the player had actually won, and vice versa. If the player won, it would look like if the computer won, it would look like the player won. So I just subtract the extra turn that I got on there. I just subtract that off to make it actually show up as which turn the last move was made on, the one that won or caused the tie. And then I go into the if statement here and I say if not won. So if this basically if this one value is still false, it would flip it to a true, which makes this true. So if you have not won yet, then that means that we exited the while loop because of the number of turns that occurred, not because there was a winner. So then I just merely say this game ends in a tie. I print that out. If that fails, it goes under the elif, which I check once again to see if the turn value, which turn we were on, if it's even, then I know the player was the last person to make a move, which means the player won. Else, if all else fails, if there wasn't a tie and the player didn't win, well then the computer must have won. So I just default to an else on there. And we'll go ahead and run this real quick. If I saved it, yeah, and you'll be able to see that. I'll go ahead and run it. I'm going to try to go for a diagonal if I can. I'm going to try to do 159 to win. I choose 1, that becomes an X. And then right there is where the AI chose. I'll choose 5. Oh, and he just randomly chooses stuff, so he wasn't smart enough to block me. So I've got 9 open. I'll choose 9, players 1. Okay. See if I can run it and let the AI win. So I'll do 1. He chose the bottom left here, so I'll choose 4. He chose this one, so I'll choose 3 to try to just let him win. And the idiot chose the bottom left one. I'll choose 6, and then where the last spot's left is 8. I have to take it, so that'll force a tie. And you'll see it ends in tie. With a dumb AI like this, it's actually really hard to lose. So I'll try one more time real quick, but I don't really see losing happening. Yeah, because he makes dumb choices like that. So I'm just gonna block 7. He takes 6. Yeah, it's gonna force a tie again. Yeah, 5, and then I choose 6 to block him. So anyway, but the point being, if he actually chose, if it wasn't a random AI, I could play this enough and eventually he'd see a win and see that it would print out that the computer wins the game, but whatever. And that's pretty much it for the program. Like I said, it's pretty rudimentary. If you want some good programming practice here, I actually did this when I first started programming. I did this initially, but I added stuff to it. Things you could do, you could set this up. You could have like a menu option or something like that. It shouldn't be too hard to add a menu in, and have it set up to where you could choose, whether to have 2 players, like a player versus player, 2 human players, or have the computers fight each other, or play against each other, or have, just the default case like we have. Like give a menu option between maybe those 3. And the cool thing about that one is you would add stuff to it, but the actual code that I have here with the check horizontal and random and all that stuff, you wouldn't have to change any of that stuff. You would just, boom, you would just add a menu, and then instead of calling, let's say for example, the idea of having 2 human players, if you just had 2 human players, you could have a while loop where instead of worrying about the turn in this case to determine who goes, you would just call choose move every single time, and then you just trust the players to alternate between who's playing with the keyboard. But you still need to keep track of the turn to know who won. Another thing you can do is add, and this would be more challenging, you can add a much smarter AI. As a matter of fact, if you want to, this is what I did, you can add a perfect AI. Tic Tac Toe is actually what's called a zero-sum game. And what that means is a zero-sum game. What that means is if you know how to play the game, if you know the tricks, the tricks, this isn't cheating. If you just know the tricks and what to look for, then you will always, always, always either win or tie. You'll never lose the game. There's other games, like there's another game called Nemesis that's the same thing, which involves like having piles of matchsticks and picking them up. Um, that's also a zero sum game, and that's basically what it boils down to. Is like depending on how the zero sums game set up, like well, I guess I made it a little bit too absolute. Zero sum games are games where you can always win or tie, but in certain situations, like the game of Nim, for example, if you know what you're doing, you'll always win. If you know the tricks for that zero sum game, you'll always force the other player to lose because there's no ties in that game. But since Tic Tac Toe doesn't offer a tie, then at the very least, you would always tie. And what you can do is program a smaller AI to have the human player play against it that actually does that, that has the perfect AI. And conveniently enough, if you look on Wikipedia, there's a strategy section that talks about playing the perfect game of Tic Tac Toe, and it tells you what to check for and what to do to get a perfect game. And conveniently enough, if you look, there's like a list of stuff, and then there's like sub options. That looks a hell of a lot like you know, like the ideas we were doing earlier, like how I was kind of just writing down my ideas and then implementing them, making an algorithm. That's exactly which is so sweet about doing the perfect AI for Tic Tac Toe is it's like a laid out algorithm. All you have to do is program it and get you some practice. But anyway, that one might take you a little while, depending on how much you mess with it and how comfortable you are at this point. But anyway, try it out, and if you have any problems, you can shoot me a message on the comments or send me an email or whatever.